Okay, good afternoon. Let us start the class. As many students are supposed to join. Okay, I'm starting with my class. Today morning we were seeing about visualization. Um, More than just presenting the data as a numerical or a categorical details, it is well we understood in the morning class, putting the data in the form of a graph, the form of a charts, the form of a pie chart, etc., gives more clear information about the trend. For example, if you see in this example, you can see the trend, right? How the a particular data keeps varying across continuously. And when I connect all these data points with a line segment, it is called as a continuous observation. I'm seeing a continuous pattern or a continuous data that is going on. So that is the reason why we go for a graph or for any other charts or maps for us to have an information or for us to understand the things. And also we saw this one thing is it is helpful for getting to know about the patterns or to know about the trend of a data. For example, the weather at Coimbatore or weather at Karunya, how actually it changes across time. It goes up and down, right? That is actually the trend. And assuming that on every Monday, it is having a very high temperature compared to the other days of the week. That itself is a pattern. So every Monday, it is actually having a very high temperature. All the other days, it is almost like going down. So this is actually a pattern. So a pattern that always it has high temperature on Mondays and other days it is slightly down. A trend, the temperature keeps on decreasing from Monday to Sunday. So that is actually the general trend and the pattern. And if any data lies far outside the original data, then it is called as a noisy data or an outlier data or an erroneous data. If I wanted to identify that is there an erroneous data or an outlier data, it is not easy for me to find out if the data set is very huge. But by plotting all these data points into the plot or visualizing it using the plots, any type of plot will help me to find out whether there is a erroneous data or an outlier data in the given data set that you are having. Okay, so that is actually the advantage of having such visualization graph. Okay, so exploratory data analysis, understanding that there is an erroneous data or an outlier data, and effective presentation, communication, or understanding or easy interpretation. All those things are the advantages factors of visualizing tools. So we already saw about the tabular data. We need to start from dot and the line chart. So I will be doing from dot and line chart, box plot, and the scatter plot now. If time permits, we will see the other plots also. So we saw about the tabular data. We saw some of the good practices of how to write a tabular data, and we saw which practice will really help me to catch the information in the given data. But according to me, like what I feel, those are the best practices. But if the data is very huge, running into a lot of rows and columns, then it is not easy. Even if I follow all the good practices, it may not be easy to understand the data or to get a pattern or get a more insight into the data. If the data is very small, of course, it is possible to have a lot of clarity on the data. So that we already saw. And the next one is the dot plot or the line plot. Line plot, generally, when I have x and the y axis, x and the y data, and y corresponds to f of x. I have a value of x, and when I apply the function, then it is y equal to f of x. And the dot plots generally show a lot of points here and there. line plots, always the line plots means all the dot points in the dot plots are going to be connected by a line and a marker. And generally the line plots are very helpful for us to show a continuous data. Continuous, what is a discrete data and what is a continuous data? A discrete data, for example, the age of a person, it is a discrete data. It
Ma'am,
doesn't have, yes?
actually students are waiting for your answer.
Okay, the dot plots are just the line plots. Dot plots means it is only the points that will be plotted here and there. Line plots means those dots are going to be connected by a line. That is actually called as a line plots. Line plots are useful to show a continuous data. For example, age is a discrete data. Every person a particular age. It's a discrete data. For example, the temperature at every hour of the day. It is a continuous data. I keep observing a particular attribute over time. That is actually called as a continuous data. And these plots provide a very good visualization. For example, you can see over here, this is your dot plot and this is your line plot. And the line plots are connected by a line segments, and this in between points are called as a markers. Okay, so the plots are going to be connected by markers, and it is useful for the continuous data, as I told you. And mostly in the line chart, for example here, if you have a categorical data, generally it goes into your x-axis, horizontal axis, and all the values, for example, the number of male and the female, the male and the female name will go into your x-axis, that is a horizontal axis, that is over here. The number of male and the number of female, that is a value, the number, the count, that goes into your y-axis. Okay, so that is what your dot and the line plot corresponds to. And as a general rule, a line chart is being used for the non-numeric x values. That is, in the morning also I told numeric, non-numeric, quantitative, qualitative, numerical, and the categorical. So categorical, non-numerical, qualitative, everything remains the same. So here I'm going to have all the, as a general rule, whenever I'm drawing a line chart, I can put the non-numeric values, x values, are otherwise non-numeric x values, otherwise I can say categorical values or the qualitative values on your horizontal axis, that is your x-axis, and the corresponding values in your y-axis. It's very, very easy. Advantages, it is very easy to understand, as you can see over here. Forget this is something temperature. You can see here how the data trend changes from one point to the another point, how the data changes. It's very easy to plot and the read, and then it shows the changes over the time. The line plots shows the continuous data, so it is
Ma'am,
continuous.
ma'am, some
Yeah.
students are waiting outside the room.
No,
Ma'am,
it's okay. It's already 3:10. Let them wait.
ma'am, they are waiting since 3:05, ma'am. You
Not
didn't
three
allow
five.
them, ma'am.
No, 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 no. Don't argue in the class. Don't argue in the class. Just now, some 2 minutes back, I admitted.
Ma'am, I only said for the students, ma'am, but you didn't admit them, ma'am.
I
They
admitted.
are only praying, ma'am.
Okay, don't disturb me. This is the last time. Okay, don't
Okay.
disturb me. Should join on time. You are all in the hostel. And this line plots always it is with respect to the time, how the data changes with respect to the temp, mostly on the continuous data, or how the temperature changes with respect to the pressure, or how the humidity and the temperature varies, something with respect to the time. And it is very useful for the comparison. And the one very important thing, never connect points for the categorical data. For example, here, as you may be seeing here, there are names. Hope you are able to see this. Let me see whether I can. It is not grouped together. You can see over here, this you can see over here, these are the names. The horizontal axis are the names, and this is the age. What is the age of James? What is the age of John? Okay, so the y-axis is the age, and the x-axis are the names. I cannot connect the James and John by a line segment. So never connect points for categorical data. I cannot connect these points with the categorical data. Are you able to understand? I can do a dot plot. For John, what is the age? I can put a dot on the corresponding age. For John, what is the age? I can put a corresponding dot for John for his corresponding age. So, but I cannot connect. I cannot connect the age of John and the age of James by a line segment. That is not actually permissible. That is wrong, actually. Hope you are able to understand. Sometimes, even if the data are if it is not a categorical data, sometimes if the data is not relevant, when I connect it with a line segment, it is going to be wrong, or it is going to mislead. Okay, see here, these are the line plots. Line plots are the markers. So these are the markers. So for every point in your x-axis, you have a marker, and these markers are connected with a line segment. Okay, so this is a line chart with the markers. You can see here it is with respect to a column A, and this is with respect to column B of this particular Excel. And here you see your x-axis is Jan to December. That's what it's shown here. And I wanted to compare three different segments: affordable segment, luxury segment, super luxury segment. There it is some data. So if, for example, it is house purchasing, affordable, luxury, super luxury. So each one of them, with respect to Jan, Feb, March, etc., up to December, each one of the rows corresponds to a particular aspect. So I can draw affordable segment as a separate line, luxury segment as a separate line, and super luxury segment as a separate line. Here, actually, it has been joined. The reason being, some cases it is worth enough to combine. Sometimes there is no need. Here you can see the trend. For example, affordable segment, which is probably yellow color. So you can see here this affordable segment, how it actually varies from one point to another point. Though it is not with respect to the exactly the numerical time, it is with respect to the month. However, you can see how the affordable segment changes across the month. Okay, so we need matplotlib and the pyplot for drawing all such graphs. For example, matplotlib. What is a matplotlib? It is a library for creating a static or animated visualizations in Python, using Python. And pyplot is actually with the matplotlib. Most of the libraries or utilities of the matplotlib is under pyplot submodule. Okay, a lot of the utilities of the matplot are available under pyplot submodule. So that's why we need matplotlib.pyplot as PLT. PLT is the alias name of this particular pyplot. So PLT dot plot. So if I wanted to draw a line plot, I can say PLT. Why PLT? Because of the import statement. So PLT dot plot. I wanted to plot. What do I wanted to plot? I wanted to plot x and the y values. I have x and the y values. And then what is a marker symbol? You can see here the marker symbol is O in this particular case. And what color do you want? Color equal to light blue, according to this example. And I can also set line width equal to 0. But many a times we will not remember all those things: color, line width, markers. We may not be remembering, so we will simply leave it as it by giving only the x comma y. And what will happen, all the other for all the other parameters, it will take the default values. So if I put plt dot plot p of y, I will get this particular answer. As you can see over here, it is a py plot. I've given a value of x and a value of y, x and the y. So we want a plt dot plot of x comma y, and markers, color, line width, everything has been given. So it takes the values of a and y, and then x and y, and it will say for value of 1 in x, the answer in y is 5. Are able to see? 1 in x, 5 is y is p, and here it is 2 in x and 6 in the other way around. That is the value of y. Okay, so this is actually called as the line plot. And now I'm moving on to the next plot. It's called as a box and whiskers plot. It is also called as a box plot. Box or whiskers plot, also called as a box plot. It is a 5 a statistical data summary. It is minimum, maximum, median, that is 25%, first quartile, then median, and then the third quartile. So all these 5 numbers will be written in order to draw this particular box and the whiskers plot. And it is almost equivalent to describe. For example, if you see here, it is almost equivalent to describe. 25%, 50%, 75%, min and the max. All these informations we generally get it in the describe. So for example, if this is going to be the median, min and the max, 25 and the 75 percentile. Is there any advantage on this box plot? Yes, you can understand the statistics, and also you can even find out the outliers using this box plot. Okay, so it can be described using the describe. You can see here, this is the median, that is a 50th percentile, quartile, which is actually middle of this 25 to 75 percentile. And this particular one, it goes from the 25 percentile to the min, or go from here 25% maximum. That is maximum. That is the minimum and maximum of the data point. You can see here the same information has been given over here. And I'll show you see here, these are the outliers. Okay. So what is an interquartile range? It is Q3 minus Q1. That is 25 and 75 percentile. That is your box plot. Here is an example of the box plot to find out the 5 number summary. The first one is I have a set of data points, and here first thing is I need to find out the median. The first step, I need to find out the median. Here there are 10 numbers. Median is the center point of the given data set. But here I don't have a center point because it's an even number. So 5 and 6 together, that is the 5th point and the 6th point together. You can see here 1, 2, 3, 4, 5 and 6. So the center points, if the number is odd, if the number of data points in the given data is odd, the center point I can directly take. But if the number of data points are Even in that particular case, I don't have one point as a center point. So in that particular case, I will take two middle points and then I calculate this average. That is your median. And what is the first quartile and the third quartile? The first quartile is the median of the data points to the left of the median. For example, what is the median here? It is 32. Though I picked 30 and 34 together, I've taken 30 and 34 together because an even number of data points. So I take 30 and 34 together and calculate the average. So 32, the value of 32, the value of 32 is actually the median now. So what is the first quartile? Whatever the data points I have on the left hand side of the median. For example, I'm writing here. Okay, so this is my median which I have derived now. It is not a part of the original data set. Okay, it's not a part of original data set, but we have calculated this median. So what is the first quartile? I need to take all these data points starting from like onto the left hand side from 32 and find out what is the middle point, that is 29. And similarly take from after 32 you take till the end, find out what is the value here, the median value, it is going to be 35. So you are having 35 here. So overall this and then the minimum and the maximum you already know. You see here, how will I draw? It is going to be PLT dot box plot. And what data that I'm going to use? I'm using stores. Stores is one of the data frame, and unit price is one of the attributes. So when I put it, I'm getting the answers like this. I can show you here. You can see over here, it is actually going to be the PLT dot box plot. Okay, and then I'm showing it. What the input that I'm giving one particular attribute. I can show you that attribute unit price. You can see here the unit price. This is what I'm trying to use it for the box plot. So that is what I'm having here, PLT dot box plot of the given attribute. So we have seen line chart and then box plot, whiskers, a box plot and the whiskers plot, which otherwise called as a box plot. And then we saw about the dot plot. And initially we saw about the tabular data. Okay. Okay, I put a form. Can you just check whether you are able to do it? Or able to open it? Can I have the response from anyone? Or able to see? Okay, okay. Thanks, Alan. Yet to get any response.
Ma'am, ma'am, for that first question, just the data visualization charts, is it supposed to be an option or like is it supposed to be whatever we can we have to write? Ma'am, you're on mute, ma'am.
Yeah, it is a short answer. It's not optional. It
Okay,
is
ma'am.
not bullets. It's a short answer.
Okay, because I wrote pie charts, scatter plot, bar graph, histogram, and I wrote exact graph. So I wanted to know if it is correct or not, ma'am.
It's correct.
Right?
Whatever we are seeing now.
Okay, ma'am. Okay. Okay. Thank you.
Okay. Only 25 have completed. I'm going to close it in 2-3 minutes time. I'm not going to take attendance. I will use this for marking attendance. Do it fast. Do it fast. Okay, I'll continue with my PPT and then I'll come back and explain the answers. Let me finish one more. Okay, the scatter plot. The next one is the scatter plot. Scatter plot means it's a type of, again, it is almost like our a dot plot where the points will be just shown as a dot plot between two variables. Actually, it is very helpful to do the correlation between any two data points using the scatter plot. You can see over here, this scatter plot is also called as a scatter graph, scatter chart, scattergram, or scatter diagram. And it uses dots to display it, and it doesn't use a line to connect these data points. And it is mainly useful for numerical data. The x-axis is called as an independent variable and y-axis is called as a dependent variable, and it is very helpful to know the relationship between these two attributes, and that is actually called as the correlation. Okay, and when to use such as scatter plots, it is to find the relationship between two numerical attributes and to find out how much both these attributes are related to one another. For example, over here, this is actually the x-axis is the age of a car and y-axis is the price of the car. And what this red point talks about is nothing but the price of the car decreases as the age of the car increases. That's what we understand from this. That's what correlation is. That's what the interpretation is from this particular plot. Are you able to get it? As the age increases, as the age of car increases, your values of your y-axis, that is your y-axis values decreases. That is the price of the car decreases. And we often see the patterns or the relationships between the between the x and the y-axis values. There are three types of correlation. One is called no correlation, another one is called positive, another one is called negative correlation. What is positive correlation? As the x value increases, your y value also increase. When the y variable tends to increase as the x variable increases. As x variable, for example, a day starting from 6 a.m. to 12 p.m. As the time increases, the sun radiation also increases, right? That is actually called as a positive correlation. Now you take from 1 p.m. to 7 p.m. in the afternoon. As the time increases, the sun radiation value comes down. That is actually negative correlation. Are you able to get it? When the morning time from 6 a.m. to 12 noon, as the time increases, your solar radiation also increases. But from 12 to 7 p.m., 12 noon to 7 p.m. in the evening, as the time increases, your solar radiation level decreases. It shows a negative correlation. So when one increases, other one also increases is a positive. When one increases, other one decreases is a negative. When there is no correlation at all, like it has been a set of data points scattered everywhere, that is called as a no correlation. And even if you are having more number of data points, that is more number of data. For example, here, this particular plot talks about Iris setosa, Iris virginica, Iris versicolor. If you remember, there is a Iris data set. That Iris data set has got 4 attributes: sepal length, sepal width, petal length, petal width. And all this, based on these 4 values, the entire data can be divided into 3 labels: Iris setosa, Iris versicolor, Iris virginica. So that data set has been used here. Using this particular scatter plot, you can see here how the data points are. So the scatter plot is very helpful to know how the distribution of the data, the spread of the data, any outliers are there, everything we can find using this particular scatter plot. And the command is plt dot scatter, within the bracket your x-axis value and the y-axis value and what color you actually want. Okay, this is a very simple one. I took the values of x and y. So for a given value of x, what is y? For the given value of x, what is y? Like that. There are only 4 data points. I said I want red color, so it is showing red color. So this is actually a positive correlation. As the x-axis value increases, y-axis value also keep on increasing. And the last one is called as a bar chart or the pie chart. Bar chart and the pie chart, this is, for example, if you see here, these are bar charts. This is a bar chart, vertical bar chart. This is a horizontal bar chart. It is also called as a stacked bar chart. And this is actually the pie chart. The pie chart is very helpful in order to show relative proportion or the relative numbers. For example, the number of faculty, the number of students, the number of NRIs, the number of non-teaching faculty, each one is a numerical number. When I put everything together, it shows a proportion of the working professionals and the students. You can discriminate, you can find out. It actually shows a partition where each one of the bars represents a frequency of a particular data or frequency of each group. What's the number of how much is the number of students, how much is the number of faculty members, how much is the number of non-teaching faculty, how much is the number of outsiders, etc., etc. So that actually called as the bar chart, pie chart. And bar chart is also helpful. For example, how many a frequency of particular occurrence. For example, in iris setosa or iris setosa, how many number of data points belongs to iris setosa? How many data points belonging to iris virginica, and then versicolor? If I'm going to draw like this, then it is going to give me a count. So that is actually helpful, called for the bar chart. You can see here the pie chart, how nice it is. And this is actually a bar chart. In this example, they have written about certain problems and what is the total capacity. And this is actually the stacked bar chart. Okay, and it is also possible to plot a lot of bar charts. If I wanted to compare many attributes, I can plot it like this so that I can compare how actually the answers are working. Multiple bar plots. Okay, so for bar plot, it is plt.bar, and for pie chart, it is going to be plt.pie. And I need to give the corresponding x and the y values. Otherwise, I need to give the x and the class labels. For the pie chart, you are going to give the frequency of the data, and then you are going to give the corresponding label. That is what it's written as labels equal to y. Okay, so I stop at this point. I need to talk a little bit more on the bar chart. So I will do it in the coming class. Okay, please check. I have launched something. Hope you are able to see. Hope you are able to see.
Yes, ma'am.
So far, I received only 2 votes. Okay. Meanwhile, okay, I close the responses. from where I will take the attendance from the poll as well as from the MCQ. I will take the attendance. Okay. Okay, let me see. Let me show you the answer for this in 2 minutes. List the data visualization charts. Whatever we are seeing now, tabular data, pie chart, bar chart, dot plot, line plot, and then box plot. All those things are nothing but your data visualization charts. I think that at least one or two some people might have written. And here, dash method in data frame provides statistical details on numerical columns. So naturally, in the morning also I asked about this. It is called describe, df.describe. That is the right answer. I'll just show you the answer here. Df.describe. So you can see here in the df.describe, you can see all the mean, standard deviation, count, all the details. So that is actually the df.describe. Someone has written df.info. What do you see in the what do you see in the case of the df.info? I have a table called stores. I put .info. It is simply going to tell which are the attributes, what are the non-null value, how many non-null values, what is the corresponding data type, and how many columns are there and how many rows are there. That is what is going to be shown in info. Remember, info open bracket and the close bracket is going to give me the list of attributes, how many columns, how many rows, what are the data types, how many non-null values in those columns or in those rows. That's what it is going to show. One interesting thing, if I'm going to take out this opening and the closing bracket, you see here, what am I getting? I'm getting the entire data. It is not the data types and the number of attributes in the columns. You see here, it is displaying the entire data that you have read. But if I'm putting opening and the closing bracket, you will see here, it is give a summary of the attributes. Hope you are listening. And similarly, in the describe, if you put the opening and the closing bracket, it will show you all the mean, standard deviation, everything, which is actually required for the box plot. But if I don't put the opening and the closing bracket, it simply displays the original table. Okay, please understand this. So the answer is df.describe. And another one, identify the package that features a number of ready-to-use algorithms for implementing data mining and machine learning tasks. It's not pandas, it is scikit-learn, which we learned in the first chapter. And a company has collected data on email, word processing documents, videos, photos, audios, etc. This data is considered as it's a composite of data. All this data are belonging to unstructured data type. It is not an Excel sheet or it is not a tabular data where I can say it is a structured data. So the answer is unstructured data. It is not quantitative, it is not categorical. When I say all the if I'm having a lot of attributes, with all the attributes are going to be quantitative, then probably I can say quantitative. If all the data that I have collected is non-numeric categorical, I can say categorical. But here it's all the different type of emails, documents, audios, videos. It's an unstructured data. Okay, it's a high time for you to recall whatever you studied in the first chapter. What is the following syntax represent? DF10 to 14. It is to pull out a subset of the rows. So it starts from 10 and it is going to be until 13. It is head minus 1 or the upper limit minus 1. So the answer is select subset of rows from 10 to 13. So these are the answers. If you have done well, it's good. Okay. Okay, so see here how many people have responded to the oaths. Only 25 people have responded to the oaths. So what actually it means? Does it mean like only 25 people are around? That's what it means. Okay. Okay, I'm stopping at this point. And whatever the questions we tried today morning, I didn't get time to put it in the Jupyter notebook. I'll do it and we will discuss it later. Okay, please go through all the documents that we are having. Okay,
Okay, ma'am.
see all the codes. Yes. Yes.